Let's discuss data presentation. Data can be presented in tables, in charts, in diagrams, because we need to simplify this data. We need to disseminate this data for common people, for policymakers. So we need to simplify this in the form of tables. We can use certain tables, we can use certain charts. We discuss this session according to following learning objectives. What is tabulated form? How tables are made? How many types of tables? Types of tables are discussed, and diagrams, bar charts, pie charts, histograms are discussed in this session. And then we'll summarize this session. How data can be presented? There are two main types of data presentation. Remember, tabulation and graphic presentation, like charts and diagrams. So we start from table. Tables, they are simple devices that are used to present the statistical data. Like we see the table of contents, or we can say that this is a table, this is the year, and this is the population. We can say that in the year 2000, population of Pakistan was 190 million. In the year 2010, that was 210 million. And in the year 2020, that is 220 million. So this is a table. It gives a quick glance, it gives a bird eye view. Someone sees the table and checks, oh, in the year 2000, 190 million. Now it is increasing. In the year 2010, it was 210 million. And in the year 2020, it is still increasing. So we need some measures. We need some control measures. We need to improve our family planning system. This gives an indication. And table should be simple. Yes. They should be simple as possible. There should be two, three tables. There can be four tables. Data should be presented according to size. Yes, size is important. Data is, let's assume that there is huge number of data. So we can simplify it. We can create class intervals. And it should be self-explanatory, like this table. It is self-explanatory that population of Pakistan is growing with time. So each row and column should be labeled. Yes, we have labeled this number of years and we have labeled this population. So labeling is must. Table should be simplified and we can subdivide the tables according to importance. Like coronavirus has importance or mortality due to coronavirus is important. So we need to describe mortality first and then other things. So we need to prioritize. What we need? We need to prioritize. Then specific unit of measure should be given. There should be unit, like there is unit of hemoglobin, gram per deciliter. We need to mention units. Like if we'll write 10, what it shows. This is just a vague number. We need to give some unit. That should be clear and concise. That should be clear, concise, to the point. Every table should contain a little as what is depicted. Table should be descriptive. There should be small table, there should be vertical line, there are horizontal lines, and data is not original. Source should be given. Like we are obtaining data from indirect source, we are obtaining data from NADRA office, we are obtaining data from passport office. So we should mention the source. This means reference should be given. Now we can create a table. How we can create a table? There are there is simple table, and there is frequency distribution table. These are types of tables. What is simple table? That simply shows relationship between two variables, like we can mention year and we can mention deaths due to COVID. In the year 2019, we just say that there were 10,000 deaths. In the year 2020, there were 20,000 deaths. And in the year 2021, there are 21,000 deaths. So this table simply shows that mortality is increasing, or it simply shows the mortality according to years. Mortality in 2019, 2020, and 2021. And what are frequency distribution tables? Like we have a data of 1, 3, 4, 6, 6, 9, 12, 15, 13, and 11. Always remember, we need to arrange data in ascending or descending order. So we can arrange this data in ascending order like 1, 3, 4, 6, 6, 9, 11, 12, 13, 15. There are total 10 observations. Now we need to calculate the range. What is range? Difference between upper and lower limit, or difference between highest and lowest value. Highest value is 15 and lowest value is 1, so range is 14. We need to divide this data. We need to create class intervals. We need to create gaps to present this data. It is 14. And how we find class intervals? Remember, class interval, we divide range, we decide number of groups. How many groups you want to create? You want to create 4 groups, you want to create 5 groups. Like, we want to create 5 groups. Desired number of groups. Range is 14 and we want to create 5 groups. So roughly class interval will be 3. Our gap between two quantities is 3. Now we will create table. There are 3 types: simple frequency table, relative frequency, and cumulative frequency. We start with simple frequency. We have created 5 groups. So 1, 2, 3, 4, and 5. Now we will find simple frequency. This is class interval. As we mentioned that it should be labeled. First we will find simple frequency. As we have mentioned that there is class interval of 3 or there is gap of 3. So we can write 1 to 3, 4 to 6, 7 to 9, 10 to 12, and 13 to 15. This covers all our observation cause our observation range from 1 to 15. 1 was lowest and 15 was highest. This covers all of them. Now we'll see 1 to 3 exists how many times? 1, 2, 3, 1, 2. So we can simply write simple frequency of 1 to 3 is 2. And then we'll see 4 to 6. 1, 2, 3. There 4 to 6 exists 3 times. Then we'll see 7 to 9. 9 to 7. Its frequency or number of times it is repeating is 1. Then we'll see 10 to 12. 1, 2. Its frequency is 2. Then 13 to 15. Its frequency is 2. When we calculate them, answer should be total number of observation, like 2 plus 3, 5, 6, 10. So our simple frequency is correct. We have found the simple frequency correctly because there were 10 total observations and 1 to 3 exists 2 times, 4 to 6 3 times, 7 to 9 was present 1 time, 10 to 12 was present 2 times, and 13 to 15 was present 2 times. So total of the number of observation was 10. When we calculate them, our answer is 10. Now we need to find relative frequency. RF indicates relative frequency. What is mean by relative frequency? Percentage of our frequency, like 1 to 3 exists 2 times. So we divide our frequency with total number of observation, and answer is relative frequency or percentage. So it's 0.2%. Then 4 to 6, our observation was 3, our simple frequency was 3. We divide simple frequency with total number of observation to get relative frequencies. So you should remember this: simple frequency divided by total number of observations. What it gives? It gives relative frequency. So if we divide 3 by 10, our answer is 0.3. 1 by 10, our answer is 0.1. 0.2, then 0.2. When we sum all these, our answer should be 1. Total frequency is 1. Remember this thing. Total frequency is 1, and we add all the relative frequencies and our answer should be 1. When we add 0.2 plus 0.3, it is 0.5. So we can add the 0.2 plus 0.3 plus 0.1 plus 0.2 plus 0.2. Our answer should be 1. Then our relative frequency is correct. What is cumulative frequency? In cumulative frequency, we add, like we can say that we got 300 marks in first year. We got 200 marks in second year. In second year, we add both first and second year marks. Our marks will be 500. In third year, we add all the 3-year marks. In 4 year, we add all the marks. Likewise, same way, we add first relative frequency in the first step. In the second step, we add first and 2. In the third step, we add first 2 and first, second, and third. In the fourth step, we add all of them. In the fifth and last step, we add all the 5. So cumulative frequency of 1 to 3 is 0.2. And cumulative frequency of 1 to 6, we need to add these 2. So our answer is 0.5. Then in the third step, we need to add these 3. Our answer is 0.6. In the fourth step, we add all the four, and in the end, we add all of them. In the last table, answer should be 1 into while calculating cumulative frequency. In the last step, answer should be 1. While calculating relative frequency, when we add all them, answer should be 1. So this is the difference between relative frequency and cumulative frequency. Relative frequency shows the part. Cumulative frequency adds on the things. So what are various charts and diagrams? Various charts are used like bar chart, pie chart, pictogram, histogram. They are most convincing and appealing method. People see and they will generate the inference. What are various principles? Every diagram must be given a title. Yes, like bar chart, pie chart. Simple and consistent with the data. Diagram should be simple. They should not be complicated. Remember, you are presenting data to common man also. So he should also get some answers of his questions, or he should also be able to interpret the data. The values of variable are presented. There are two axes, x-axis and y-axis. Some values are presented on x-axis and some are presented on y-axis. There are number of lines drawn. Scale of presentation. Yes, that's important. We should divide the axis. Now discuss bar chart. Remember, few things to remember. Bar chart shows qualitative data, or it represents qualitative data. This is a common MCQ question. What bar chart represents? Or bar chart is used to represent qualitative data. Bars can be vertical, they can be horizontal. Suitable scale is chosen that bars are usually equally spaced. Yeah, you should have a space. So there are three types of bar charts. Simple bar charts. It shows one variable like population. This is simple bar chart. Multiple bar chart categorize. We categorize variable like we categorize population according to area. That is multiple bar chart. Component, when we divide them in according to composition or divide them in components like composition, we can say our composition of our population. These are children, these are males, and these are females. This is component bar chart. Like this is simple bar chart. Simple bars are given. When you compare two variables, this is complex or multiple bar chart. And when we divide it into component, this is component bar chart. So there are three types of bar chart. It can be a university question, simple bar chart, multiple bar chart, and component bar chart. And bar chart represents qualitative data. So you must remember qualitative data. What is pie chart? It entire graph looks like a pie. We divide the percentage according to angles. Like suppose there are a total angle is 360 degree and total percentage is 100%. So 1% is equal to 3.6 angle. Represent them in angles like sections of a cricket match. That one section is dominated by this team, one section is dominated by this team. We divide the frequency according to this. The line diagram, it is the relationship between two variables. When you see a cricket match, there is a relationship between number of overs and runs. Overs are increasing and runs are also increasing. This is line diagram, relationship between two variables. This is line diagram. So remember, line diagram shows quantitative data, or it represents quantitative data. Then histogram, it is graphical representation of frequency distribution table, or you can say that when we make a diagram of frequency distribution table, a diagrammatic form of frequency distribution table is histograms. There is no space between different bars. Like we explain number of hours of a baller from 1 to 10, there is no space. These are rectangular, these are rectangles. So this is histogram. And remember, it represents quantitative data. This is a common university MCQ that a histogram represents quantitative data. Frequency polygon, it is obtained by joining midpoints of different histogram blocks. Like these are histogram blocks, and we join midpoints that curve is going upwards or curve is going right downwards. Like in space of 5 hours, we say that runs are increasing in some hours, they are decreasing in some hours, then they are again increasing in some hours. And when we unite midpoints, we get frequency polygon. And frequency polygon also represents quantitative data. Then pictogram. Countries like Pakistan, where majority of population is not educated, we give pictures. We present the data in form of pictures. Like we want to indicate that infant mortality is increasing. So to depict infant mortality rate, we show it in the form of pictures. Then there are spots and maps. We form certain maps. Now we'll summarize. We have discussed presentation of data. Data can be presented in the form of tables and charts. What are tables? There are two types of tables: simple tables and frequency distribution tables. Frequency distribution table like simple frequency, relative frequency. We find cumulative frequency from these tables. Charts, there are bar charts, there are pie charts, then there are histograms, frequency polygons. Then remember, there are two types of data: qualitative data and quantitative data. Qualitative data is represented in the form of bar charts, pie charts, and pictogram. This is a common MCQ. Then quantitative data, it is represented in the form of histograms, line diagram, frequency polygon. This is representation of data. So till then, we have covered tables. We have covered that data can be presented in the form of tables. Tables can be simple. They can be frequency distribution tables. Then we discussed that it is presented in the form of diagrams, charts. They give a quick glance. They give a bird eye view to the reader, like bar charts. There are three types of bar charts: simple, component, complex bar charts. Then data can be presented in the form of pie chart in angles. Then pictogram, where pictograms are used, they are used for illiterate people. Then we discussed that data can be presented in histogram form, like when we unite different bars, it becomes a histogram. A histogram is the graphical representation of frequency distribution table. Then we discussed frequency polygon and line diagram. That's all.